Okay, let's dive into this stack of sources we've got here, all about the Model Context Protocol, or MCP.
Right.
This is a topic buzzing right now, and this deep dive, it's specifically for you, the listener, if you want a quick but, thorough understanding of what MCP is.
Yeah, and why everyone keeps calling it the USB-C of AI.
Exactly. And how, according to these documents anyway, it's fundamentally changing what artificial intelligence can actually do.
So our mission really is to pull out the most important nuggets of knowledge from this material, figure out what they actually mean, and connect the dots.
Connect the dots, yeah.
We want you to walk away feeling truly well-informed about what the sources are describing here as a potentially transformative development in AI.
Exactly. Think of MCP, like as these sources present it, as this pivotal new layer, a kind of universal connector, designed to let AI applications talk seamlessly, effectively, with all sorts of external services.
Yeah.
Tools, databases, even reusable templates.
And it's built to tackle a huge, messy problem in AI integration that's honestly been holding things back, a real bottleneck.
Yeah, big one.
And here's where, reading these sources, it gets really interesting. It's not just about connecting AI. It's about enabling AI to actually do things out there in the real world.
So what does all this mean for you? Let's unpack it. At its heart, MCP, as defined in these sources, it's a standardization layer. Simple as that, kind of.
Well, simple concept, maybe, its primary purpose, to enable genuinely effective communication between AI applications, especially LLMs or, large language models and everything outside of them.
Those external services, tools, databases, templates.
All that stuff. And importantly, it's put forward as an open standard, an open source framework. That's key.
It is key. And one striking thing the sources keep coming back to is that analogy. MCP is frequently compared to the USB-C of AI apps.
Yeah, I like that one. Remember how USB-C aimed to be that single port for everything, charging, data, video?
Simplified everything.
Yeah, exactly. MCP has a similar ambition, but for AI integrations, connecting models to tools and data.
That analogy really sticks, doesn't it? It immediately conveys not just the technical idea, standardization, but the practical benefit.
Definitely. Easing integration pain points, drastically reducing friction for developers, and ultimately for users, too. It just makes things simpler.
And that simplicity addresses this massive headache that plagued AI development before. Anthropic, they're the ones who introduced MCP.
Right, Anthropic.
They characterized it as solving the NXM integration problem.
The NXM. So if you think of N as all the different LLMs out there.
Dozens, hundreds eventually.
And M as the countless external systems or tools you might want them to connect to. The old way, it basically required building a custom connector for almost every single unique pairing. N times M connections.
Which just sounds incredibly inefficient and brittle. Like trying to build some complex system where every single wire needs a totally custom one-off connector plate.
Pretty much.
What were the real-world consequences of that?
Oh, it led to fragmented, cumbersome, and incredibly difficult to scale AI deployments. Just messy.
I bet.
You ended up with significant inefficiencies, major scalability hurdles, inconsistent user experiences, and just a huge amount of overhead, managing all these different tools, trying to orchestrate workflows.
And the LLMs themselves were kind of stuck, weren't they? In information silos, unable to get the real-time data they needed.
Exactly, because LLMs are inherently limited, right? They're trained on a static snapshot of data. They're constrained by their context windows.
Right, they can't just browse the live web or check your latest database entries on their own.
Not without help. Without a standardized way to reach out and, touch the dynamic world. They're kind of stuck in their own heads, like you said.
Okay, so this is where MCP steps in. By establishing this standardized protocol, it functions like that universal wiring system or a smart switchboard.
That's a good way to put it. A smart switchboard. It enables what the sources are calling plug-and-play integrations. You build or adapt your external service once to speak the MCP language.
Just once.
And theoretically, any MCP-compatible AI application can then interact with it. No more NXM custom builds.
So it fundamentally addresses that painful NXM problem by providing a common language layer, like Esperanto for AI tools.
Maybe. Precisely. And this massively accelerates AI adoption. It also makes it far more economically viable.
Right, because companies aren't spending huge amounts of time and money building that, what did the sources call it? Undifferentiated heavy lifting.
Yeah, that undifferentiated heavy lifting of custom integration glue every single time they want an AI to talk to a new system.
Okay. And connecting this back to the bigger picture, the standardization. It fundamentally addresses the LLM's static knowledge limitation
It does. It helps transform LLMs from just passive knowledge lookup tools.
into truly intelligent, context-aware entities that can actually perform actions in the real world. This is like foundational to this whole idea of agentic AI, isn't it?
That's the critical shift that the sources really highlight. Moving from an AI that can describe how to, say, book a flight to one that can actually book the flight for you.
Describe versus do.
Exactly. MCP is presented as the key enabler for that transition.
Okay. Anthropic publicly announced MCP in November 2024. What struck me reading these documents is how quickly it seems to have been picked up.
Seriously, rapid adoption. It's kind of amazing.
Yeah.
The sources point out that major industry players, OpenAI, Google DeepMind, Microsoft, they're already integrating it.
Wow.
So this isn't just some niche standard floating around. It's rapid uptake. It really underscores its potential role as what the sources call a platform primitive.
Platform primitive.
Yeah.
Like TCP/IP or HTTP for the internet. Foundational stuff.
That's a parallel they draw. Protocols that enabled huge waves of innovation. MCP could be that for AI interaction.
And that strategic choice, making MCP an open standard, open source, that seems absolutely crucial to that rapid adoption, wouldn't you say?
Oh, absolutely. Critical. By not keeping it proprietary, Anthropic made a very smart strategic move.
Yeah.
It encouraged widespread adoption, even by competitors, and it gets the broader developer community involved.
Minimizes vendor lock-in.
Right. And it fosters collective innovation. That's the fastest way to build a thriving ecosystem around a new standard. Think about Linux or Kubernetes. Their openness was key.
Makes total sense. Okay, now looking at the design philosophy, where did they get the inspiration? The sources mention the architectural design incorporates concepts from the Language Server Protocol, LSP.
Ah, LSP. Yeah, that's widely used in coding environments, right? Like in VS Code and other IDEs.
Exactly. It provides a standardized way for different programming language tools like code completion, error checking, formatting to talk to the editor itself.
Okay, so leveraging something proven.
Right. Building on a battle-tested standard like LSP gives MCP a proven, robust, and importantly, extensible communication model. And for the underlying message transport, they chose JSON RPC 2.0.
Which is known for being pretty lightweight and efficient for client-server stuff.
Yeah.
So it's pragmatic, really. They didn't try to reinvent the wheel for basic communication.
Makes sense.
By leveraging standards developers might already know, they, reduce the learning curve, speed up adoption, and build on a foundation people trust for stability and reliability.
And this stands in contrast to some earlier attempts we saw, right?
Yeah.
Things like OpenAI's function calling.
Yes. Those earlier approaches, like OpenAI's 2023 function calling API or the original ChatGPT plugin framework, they often required vendor-specific integrations, still somewhat tied to a particular model or platform.
More of those custom connections, again, just maybe at a slightly higher level.
Kind of. MCP was designed explicitly from the ground up to be universal and model agnostic.
Okay.
And this evolution, which the sources definitely highlight, it signifies an industry-wide trend, moving away from those walled gardens towards open, interoperable ecosystems. It's about establishing a common language for AI to interact with the digital world, regardless of which specific LLM is doing the talking.
Okay. That shift towards a common language is powerful. So how does this common language system actually work? Let's get into the architecture a bit. The core model is described as client-host-server.
Right, the client-host-server model. And this architecture is key because it provides modularity, separation of concerns, and benefits like scalability and fault isolation, which are all good things.
Definitely. Walk us through the roles. What's the host doing in this picture?
Okay, the host. That's typically the LLM application itself, or maybe the IDE where you're interacting with the AI.
So like Claude Desktop or Cursor or Microsoft Copilot Studio.
Exactly. The host acts as the conductor of the orchestra, maybe. It initiates the connections to these external services, manages the life cycle of those connections, and critically, it's responsible for security policies.
A lot of security. Important.
Very. The host handles things like permissions, making sure the user has authorized access, managing consent before the AI can use certain tools or touch certain data.
So the host is essentially the central security gatekeeper, controlling what the AI is allowed to access or do based on user permissions. That seems absolutely essential, especially for businesses using AI with sensitive data.
Absolutely critical for enterprise adoption, for trust. You need that control layer. So that's the host. Then you have the clients.
Okay, clients.
These are lightweight components, usually embedded within the host application itself. Think of the parts of, say, IBM BAI or Claude.ai that actually use MCP.
Gotcha.
Each client typically maintains a dedicated, secure one-to-one connection with a specific MCP server. They handle the nitty-gritty of the session, keeping the connection alive, managing interruptions or timeouts, and importantly, they enforce strict security boundaries. They prevent, for instance, one client session from accidentally snooping on data or tools meant for another session or another user.
Okay, got it. So the client is like the secure phone line keeping conversations separate, and the servers, what do they do?
The servers are independent processes. These are the components that actually do things or provide the data. They expose specific capabilities, accessing data, providing tools, offering predefined prompts, and they adhere to the MCP standard.
So an example might be like a GitHub server using MCP, or one for a specific database.
Exactly. An MCP server for GitHub that lets the AI interact with repositories, or one for a PostgreSQL database that lets the AI query it directly. The host integrates the capabilities exposed by these various servers to enrich the LLM's understanding and, crucially, enable it to act.
That modular design sounds really smart. The LLM and the host can focus on the reasoning part, the thinking.
Yeah.
And the servers handle the specialized external functions. So if my GitHub server has a temporary problem, my whole AI app doesn't necessarily crash.
Exactly right. It just loses access to that one specific capability, hopefully gracefully. That's the fault isolation benefit.
Okay.
And it massively simplifies integrating existing enterprise systems. You just need to build or find an MCP server that acts as a bridge to your existing system.
Rather than trying to deeply wire every single tool directly into the core AI application itself.
Precisely. Much cleaner, much more scalable.
Okay, that makes sense. Now, within this model, what are the types of capabilities these servers expose? The sources talk about core primitives.
Yes, the core primitives. These are kind of the fundamental building blocks of interaction in MCP. The first one is tools.
Tools. Okay, and these facilitate actions or information exchange that have what was the term? A side effect?
Yeah, a side effect, meaning they actually change something or trigger an action outside the AI itself.
Like executing a calculation that stores a result, or making an API request that updates a record somewhere, or initiating some process.
Exactly. They allow the MCP server to invoke external services on behalf of the AI model. Specific examples the sources give include things like a tool called lookup customer by mail.
Okay.
That not only fetches data, but might also log the lookup action that's a side effect. Or maybe query threat DBI, which queries an external security system and could potentially update its state or trigger rate limiting.
Got it. So actions with consequences. And they're formally defined.
Yeah, using structured formats like JSON schemas, plus human-readable descriptions so the AI can understand what the tool does and how to use it properly.
Okay. Tools. What's the second primitive?
The second is resources.
Resources. And these provide access to data sets, structured or unstructured. But the key difference is they are read-only.
Fundamentally, yes. Read-only data access. They have no actionable computations or side effects on the external system itself.
So think like accessing a product catalog, retrieving user records, pulling up logs of customer interactions.
Exactly that kind of thing. Pure information retrieval.
Okay, so the critical distinction here is tools do things. They have effects, while resources simply provide information. That seems important.
It's crucial, and the sources really emphasize this distinction, especially for security and control.
How so?
Well, tools inherently imply higher risk because they can modify external systems or trigger real-world actions. Resources are generally lower risk.
Right.
This separation allows for much more granular access control. You can easily grant an AI permission to read customer data via a resource.
But not necessarily update it via a tool unless that's specifically authorized.
Precisely. It enables proper auditing, supports the principle of least privilege, all vital for responsible and secure AI deployment, especially when you're dealing with sensitive enterprise data.
That makes the distinction very, very important for trust and safety. Okay. And the third primitive is prompts. This isn't just the user typing something in, is it?
No, not exactly. In the MCP context, prompts are more like reusable templates or predefined workflows for communication between the LLM and the MCP server.
Ah, okay. Standardized instructions.
Yeah. They're designed to optimize AI responses, streamline repetitive tasks, and ensure consistency in how the AI interacts with the tools and resources.
So it's standardizing how the AI uses the tools and resources for certain tasks, not just standardizing access to them.
Exactly. You're standardizing the interaction pattern. An example from the sources might be a structured prompt like, Summarize the sentiment history for customer ID X using the customer interaction logs resource.
Okay, so it guides the AI's process.
Right. This primitive is crucial for building reliable, predictable, and scalable AI applications and agents. It moves beyond simple ad hoc user queries and helps ensure the AI interacts with external systems in a controlled, repeatable, and trustworthy manner.
Got it. Tools, resources, prompts. Makes sense. Beyond the architecture and primitives, the sources briefly touch on other elements. Protocol layer, transport layer, message types. These sound like the plumbing.
Pretty much the essential plumbing, yeah. These are the technical details that make the communication robust and reliable. The protocol layer handles things like, message framing, linking requests to their responses so nothing gets lost.
Standard stuff for protocols.
Yeah. And the transport layer uses protocols like JSON RPC 2.0, as we mentioned, but it's flexible. It supports things like standard I/O, CDO for local communication, maybe between processes on the same machine, or HTTP with server sent events, SSE, for more scalable remote deployments over a network. That flexibility is practical for different operational needs.
Right, local dev versus cloud deployment.
Wow.
And having defined message types like requests, results, errors, notifications, that ensures predictable communication.
It does. Predictability is vital, especially when you start building complex multi-step workflows where the AI might need to use multiple tools sequentially or handle errors gracefully if one step fails.
Excellent.
The sources also describe a defined connection lifecycle. It's not just turning on a switch. There's an initialization handshake, a period of message exchange, requests, responses, notifications, and then a defined termination process for clean shutdown or handling disconnects and errors.
So the connection isn't just suddenly active or dead. There's a proper process for starting, interacting, and ending.
Exactly. This defined process ensures both the client and server always understand the state of the connection. That's fundamental for robust, predictable, manageable interactions. It enables proper error handling, graceful resource cleanup. It underpins the reliability MCP is aiming for.
Okay, wow. We've gone pretty deep there, from the high-level problem down to the architectural nuts and bolts and the types of interactions. Let's pull back up to the big picture again.
Yeah.
The transformative power and impact of MCP, that standardization and interoperability aspect, feels absolutely foundational.
It really is. The fact that it's an open standard fosters collaboration, allows for a massive ecosystem to develop around it quickly. It creates this model-agnostic universal interface.
The USB-C idea again.
Yeah, essentially allowing developers to write once for how to interact with a type of service via MCP, and then theoretically use that integration with any compatible AI model.
Which dramatically reduces all that custom glue code we talked about. Makes systems way more maintainable, I'd imagine.
Absolutely. And one of the most exciting impacts, according to these sources, is the potential for the democratization of advanced AI capabilities.
Democratization? How so?
By simplifying these complex integrations, MCP drastically lowers the barrier to entry. It means it's not just the giant tech companies that can build sophisticated AI agents.
Right.
Smaller teams, individual developers, organizations of all sizes, they can potentially build AI agents that can interact meaningfully with real-world systems, not just chat abstractly. It aims to make AI actually useful where it matters most, interacting with your specific data, your specific tools.
That makes total sense. And that modular client-host server design, combined with the standard primitives, it enables a kind of composable AI ecosystem, like building with Legos or microservices.
That's a great analogy. You can combine different MCT servers, your GitHub server, your database server, a calendar server, whatever emerges like building blocks.
Mix and match.
Yeah, mix and match to create incredibly complex, specialized AI workflows tailored to specific needs.
And this composability also reduces vendor lock-in, right? Encourages innovation because you can pick the best tools and data sources as long as they speak MCP.
Exactly. As long as they adhere to the standard, you can integrate them, encouraging competition and choice in the ecosystem.
Okay, so summarizing how MCP fundamentally enhances LLM capabilities. First, it gives them access to real-time information.
Check. Up-to-date data from databases, web searches, whatever resources provide.
Second, the big one, the ability to perform actions in the real world.
Yep. Using tools to update documents, perform calculations, automate tasks directly. It bridges that gap between isolated intelligence and dynamic functionality.
That describe versus do distinction again. Foundational to agentic AI, and MCP is the key enabler.
Absolutely.
Third, it provides the AI with much richer context by pulling in all this external data via resources, which should lead to more meaningful, comprehensive responses. And hopefully, help reduce hallucination.
Yeah, better context generally means more grounded, relevant responses. It anchors the AI in reality.
Make sense.
And fourth, it enables things like dynamic tool discovery and orchestration, the AI potentially figuring out which tools it needs for a given task and how to sequence them. And finally, it provides the framework for building autonomous workflow definitions, allowing AI to manage complex, multi-step processes without needing constant human handholding.
Okay, so connecting this all back, why does all of this matter specifically to you, the listener?
Well, it's fundamentally changing the capabilities of the AI systems you interact with every day, or the ones you might build or use at work in the future,
They're moving beyond just conversation and information retrieval.
to being active participants. Agents that can take action within your tasks and workflows in the real world using your tools and data.
Okay, so the core takeaway from wading through all these sources is pretty clear. MCP looks like a pivotal advancement. It standardizes how AI interacts with external systems.
It tackles that painful NXM integration problem head on.
And it's fundamentally enabling the rise of agentic AI that can actually do things.
With its key features being an open standard, that robust client-host-server architecture.
And those crucial primitives. Tools for action, resources for data, and prompts for standardizing interaction patterns.
Plus, a clear focus baked in on security and predictable communication.
And its rapid adoption across the industry. It really suggests it has the potential to become a foundational platform primitive for this AI native era we seem to be entering.
That's the trajectory the sources point towards. Now, they do acknowledge, there's ongoing work, areas like advanced security oversight, specific authentication methods, monitoring standards. These are still evolving.
Right. It's not finished day one. The community is actively tackling these things as the standard matures.
Exactly. It's a developing story for sure, but the direction seems pretty clear.
So maybe a final thought for you, the listener, to mull over, drawing from all this. Given that AI is moving from merely telling you things to being able to actively do things in the real world using standards like MCP, how do you think this will fundamentally change the way you use technology, interact with information, and manage your tasks in the coming years?
Yeah, what does it mean when your AI assistant can not just find information, but actually act on it using your approved tools? Something to think about.